In this video, I'm going to give an overview of 1D kinematics. So this is often the first subject usually taught in physics. Kinematics is the study of motion of objects through space. And in kinematics, we don't consider the object's mass or force acting on it. So again, kinematics is the study of motion of objects, bodies, or systems. And so there are three main things we use to describe motion. One, position. Two is velocity. And three is acceleration. So first I want to talk about position. So with position, there are two kind of concepts associated with it. Distance and displacement. So kind of show the difference between the two. Let's say we have a person that runs a lap on a track. So usually most tracks are 400 meters. So a person runs one lap. The distance they've traveled is 400 meters. That's the amount they cover, or have the amount they've traveled. The displacement here is 0. Displacement is like the change from the initial position to the final position. So they start off at this point, ran a lap, and end up at the same place. So their overall displacement is 0. Another example is a person, let's say they walked 4 meters to the right. And then they walk back 3 meters. The distance traveled is 7 meters. They walked 4 and then they walked 3. That's distance. The displacement, so they started off here and their final position is here. So their displacement is plus 1 meters to the right. Okay, so the second one is velocity. And with velocity, there's speed and velocity. And so speed is distance over time. It's the rate at which an object covers a distance. We use speed a lot to describe how fast a car is going. For example, 30 miles per hour, 60 miles per hour. Velocity is pretty much speed, but with speed with direction. So for example, you might say a car is traveling 60 miles per hour, and that's speed. With velocity, though, you also will say, okay, the car is traveling 60 miles per hour in this direction, or in this direction, or this direction with an angle. So these are all things, vectors, and that is associated with velocity. You need to specify the speed with the direction the object is actually traveling. Now acceleration, so as velocity was kind of the rate of at which an object covers distance, acceleration is the rate at which an object changes velocity. And velocity is the rate at which an object changes distance. So let's say we had a car and it's traveling at a steady 60 miles per hour. And this speed is constant. That means that this car has an acceleration of 0. Now let's say that the car instead is at rest, and then it starts to speed up and then gets to a speed of, let's say, 60 miles per hour. In this case, the car has a positive acceleration. The velocity is increasing, and so it has a positive acceleration. If the car had started off at 60 miles per hour, let's say the car is starting off 60 miles per hour, and then it starts to slow down and then brakes and gets to stop. So stop. So here it's velocity 0 miles per hour. In this case, the car has a negative acceleration. The velocity is slowly decreasing. So when an object has a constant acceleration, there are a set of equations we use to describe the motion. It involves 5 different variables. So one second, I'm gonna clear all of this. Okay, so again, when an object has a constant acceleration, A, there's a set of 5 equations, a set of 4 equations you can use to figure out certain parts of its motion. So there's 5 variables: displacement, and sometimes you'll see this also in textbooks called a change in x. You have the time, acceleration, the initial velocity, and the final velocity. And so the 4 equations, which are often called equations of kinematics, are v final equals v initial plus acceleration times time to v final squared equals v initial squared plus 2ad. Again, this d is not distance, it is displacement. This d, displacement. And the difference is what I covered when I went over that example with the track. So here, displacement equals, third equation is displacement equals initial velocity times time plus 1/2 at squared. And 4, displacement equals v initial plus v final over 2 times time. So I'll try to create another video where kind of going over where these, how these equations are derived. But as you go through problems and use these will kind of become second nature, and you won't have to keep looking at sheets to remember them. So one common scenario in which we use these equations is when an object is falling in space. It's kind of oftentimes will be called free fall. So let's say we have this cliff and someone drops a ball and it's falling down. And this ball has an acceleration due to gravity. And on Earth, that's actually a known value. Acceleration of an object in free fall that's just falling is negative 9.8 meters per second squared. A lot of times this will also be called g, acceleration due to gravity. So this is kind of a brief overview of kinematics in 1D. So the next several videos we'll go over problems, and then the next section will be 2D kinematics. Thanks for watching.